Fifth webinar in the DBA Madness series. March is almost over. Can you believe it? March has been a very long month, it seems like, with all the constant announcements on the TV. The weather has been maybe a little bit dreary over here, at least, even though I know Crystal has beautiful weather, but it's just been kind of a long month. And it's been a wonderful experience talking to all of you. I've had a lot of fun doing this one, and this is the last one. This is one of my favorite topics. This is either going to be a somewhat short or maybe a too long presentation. We're going to go into we're going to do a deep dive into the parts that make how Azure works as far as storage goes, the throttle points that Microsoft has put into place. Who am I? As most of you who have been watching these now know, I've been a senior database administrator for quite a long time. That goes kind of a funny story. It goes all the way back. I was a Unix administrator, and after successfully doing the Y2K exercise, I was asked if I wanted to be a DBA, and I said sure. So it just kind of went from there. And I was tossed right into the cauldron learning about Oracle and just went from there. So I've spent a lot of time working on Oracle. I spent a lot of time working on SQL Server. I spent a lot of time working on Ingress, including a lot of different OS platforms. And I'm kind of up in the air if people have opinions on this one. I don't know if it's right to call Azure an OS platform, even though I've been kind of thinking like that. It's an ecosystem. But it really is just another platform. There's a lot of topics about, what should DBAs be doing, and learning Azure is good, but it's just taking advantage of the knowledge that you already have and just put it into a different environment. I'm also in the leadership group for my local SQL Server user group, and the SQL Server groups are adapting to the stay-in-place restrictions, and they are doing online presentations. So there will still be meetings. I still want you to reach out to your user groups, join in, and enjoy yourself. Once again, get that great experience talking to other technologists about topics that you love. One of the things that I am not doing right now is SQL Saturdays, because SQL Saturdays are on hold temporarily until things are sorted out as far as the social distancing. But along that line, I heartily recommend that you think about a topic that you could talk about for 5 minutes, 10 minutes, 15 minutes, 60 minutes. Reach out to your user group leader and say, hey, I'd like to do this presentation. And I guarantee that they would be happy to have your input and would love to have you present to the group. So it's a great opportunity, and I can't recommend it enough. I mean, it's a lot of fun. And you're gonna get a lot of support too. I mean, it's not like you're gonna just be doing this all by yourself. You're gonna get support from the group leaders, from the group itself. You'll get some good feedback, and you'll be able to move forward on that. Big on community. Go out to Twitter, look up SQL Family, hashtag SQL Family, look at all these people. People are out there talking about stuff, they're talking about important stuff, whether it be professional or personal. But the main thing is that that group is out there for you to lean on, and I think it's a good idea to be part of that. Finally, go to pass.org and sign up. It's a free membership. You can join a worldwide organization of, PASS is an acronym for Professional Association of SQL Server, and so much more now. But it's a great group to be part of, and they've been doing tons of free webinars, places to look for jobs. It just, again, looking for that support. So Azure Performance. So the ones of you who were here for my second webinar on Lift and Shift, we talked about the differences between going from a traditional on-prem data center to Azure. And I think one of the things that I didn't point out in that presentation that I want to present here is that what Microsoft has done is that they've put all the controls in via software. They're not via hardware anymore. So in your traditional on-prem data center, you have your server that you're assigned to. Your server is probably virtualized, and maybe it's one of many servers on a big server. And you have a certain amount of RAM assigned to you. You have a certain amount of CPUs. You have a certain guaranteed performance level that's going to be coming through. But that's all ultimately due to the hardware that's assigned to that. I mean, there's software controls. So the difference in Azure is that everything is completely virtualized, and your big pipe is network. But what they've done is that Microsoft is it's very clever what they've done, but they've figured out a method in order to give you exactly what you're paying for. You're paying for a service, and along with that service comes with a lot of extra bonuses because they're giving you a huge amount of redundancy. We also talked about that in the DR one, is that when you sign up for Azure, I mean, you're getting, even at the lowest level, like the SQL Azure level, you're getting your data copied 3 places for redundancy. And you can have things copied all over the place. I mean, you can guarantee that you will never lose anything whatsoever. But because of that, there's some certain limitations, and that's what we're going to be talking about. And as you'll see a few cat pictures in this one. Again, the Catio on the left is to represent your on-prem data center. You're paying for a service, and you're getting a certain amount of space to stretch your legs virtually, as it was. They're going to give you this allocation, and you will be able to use as little or as much as you want, but you're going to be paid the same, you're going to be charged the same price no matter what. On the other hand, the Japanese cat who has shoved himself into the tiny little box, he's exceeding the performance guidelines for his Azure environment. And because of that, he's stepped in there and he can't go any further. So that's just something you have to be mindful of, is that you can pay for the Catio on the left, but if you're going to try to pinch your pennies, you're going to get the little cardboard box on the right. We're going to go over some basics here. Especially people who worked with OSs, but these are terms that you may not have heard in a while, but we're going to go over these different terms and talk over in detail. Compute, that is the industry standard referring to the actual server itself. That is your server chassis, virtualized, the CPUs, and the RAM that's associated with it. IOPS, inputs, outputs per second. Throughput, that's how much data is being moved. Latency, that's how long it takes for something to respond. And so, for instance, if you were playing a game online or something like that, and you were to click your mouse, the latency would be how long it would take for once you clicked your mouse for some reaction to happen on the screen. Queue depth, that is a measure to show how many commands are pre-allocated and processed by the CPUs and have been assigned to the disk. So it's a queue. It's a collection of things, of actions waiting to happen. Outstanding IOs, those are the actual actions waiting to happen. Queue depth is just the number of them that are waiting. DTUs, we're not going to talk about SQL Azure unless we have a lot of extra time in this presentation. DTUs and vCore are specific to the Azure SQL environment. And originally I wanted to talk about that, but then I said that we'll save that for another webinar because there's a lot of information there that I think deserves its own webinar. Asynchronous IOs. So that would be your classic database activity. That's going to be everything, all of your random seeks to your drives. It's going to be pretty much most anything in a database, whether a user opens up an application and they have to pull tables, information from tables. It's going to be when they update records on, for instance, like vendor or customer records, those asynchronous IOs, and that's going to make up 95% of the traffic in a database. Synchronous IOs refer to your log writes and your backups, because in order to maintain consistency in your database, you have to, concurrency really, you have to make sure that everything is stacked in place. For instance, for a backup, you want to go ahead, you obviously would want to make sure that the backup goes from point 1 to point 100. You wouldn't want it to go from point 100 to point 70 to point 85 to 6 to 20 to 1. You get the idea. Again, you want to have synchronous IOs, that every piece of that backup is written to the disk, it's verified, and then it goes back and says, can I please have another one? Same thing with your log backups. Why are we doing this? I think it's important. I've had some professional experiences where the performance was not quite what was advertised by Microsoft. And again, it's not the fact that Microsoft is doing something wrong. The important thing here is that there's a lot of documentation out there that you have to read, and it's not the easiest thing to read. And because of that, it's easier to make the decision to go ahead and just migrate to the cloud. And probably you're going to have an okay experience migrating to the cloud. But what I do want you to have the ability to do here is to be mindful of the expenses, because as we all know, it's not cheap in the cloud. And so I think it's very important to understand what you're getting into, much like if you were to go to a restaurant and let's say you were to order a steak or something, and then you get charged for add-ons, like maybe you wanted your mushrooms or your onions or something like that. But the point is that you have to be aware of all the different options that are out there. And as you've seen this picture before, we don't want your users calling up and saying, where's my data? Throttle points. We're going to talk about that a lot, and we're going to talk about IOPS a lot too. It's not magic, it's accounting. Again, Microsoft has come up with a great system in order to allow you to allocate you the performance that you paid for. Again, keywords, what you paid for. Why did they do this? They set this up because they're going to maintain integrity above all else, and we should applaud Microsoft for doing this. Again, if you start going through the different Azure levels, even at the basic, if you just put a VM into the cloud, I think, if I remember correctly, I think it's 99.5 SLA they're promising you. If you add in an availability zone or availability group, it goes up to 99.99 of SLA. So Microsoft is making sure that above all, that you are not going to lose your data. If you are entrusting your servers, your data with Microsoft, they are going to make sure that you get it back. And all the different features coming from their, for instance, like on SQL Azure, the fact that they do a full backup immediately, they do backups constantly. You don't have to think about it. Same with the VMs. You do have to schedule your SQL Server backups or whatever application you may be running the VM. But again, they are backing up that VM as well. I mean, the whole environment's being taken care of. But because of this, the price that you're paying is that performance may be, you may lose some performance because they are making sure that that data gets written to the disk when they promise it's going to be written to disks, and they want to make sure it's recoverable. Throttle points. So you can look here at this confusing, well, it's not that confusing, but this diagram right here from Microsoft. This was explaining how, again, we are talking about VMs now. We're not talking about SQL Azure, we're talking about VMs. So this is if you had taken a probably already virtualized server from your on-prem environment, whether it be in your local data center or a remote data center, and then you have taken the virtual disk copies and you've loaded them up to Azure and you've restored them into your Azure environment, thereby restoring your server. In the lift and shift environment webinar, we talked about the sizing. We're not going to talk about that, but here's where you look at actually the disks. So as you can see here, there's a lot of labels on here that talk about throttling. So the important part to remember is that there's three different levels of throttling that goes on into an Azure VM. You have your disk level throttling, you have your VM level throttling, and then both the cached and the uncached throttling. We're not going to go into great detail at all, or really any detail at all on the caching. It's a big topic, and I felt that we had enough information right here to talk about. I will say that overall, I'm going to recommend using caching on the VMs. For your OS disk is automatically cached read-write. But when you're setting up your VM, if you have a separate, you should have a separate data disk for your databases. Go and set that up for read caching. That's considered a best practice by Microsoft, and you're going to see a lot of good things happening there. For your independent disk, for your logs and your tempdb, no caching. So that's why caching is important, but it's not as big a topic as it could be. So going back to the throttling, you have the throttle points. The main thing that's happening here is that when you're paying, you pay for a certain level of service with Microsoft, both on the VM level and the storage level, and they all come with a maximum cap. If you exceed that cap, your performance is going to be throttled, because that's what you've paid for, and that's what they're guaranteeing you, and they're not going to give you anything else. And we're going to talk about both independent and dependent throttling. Let's see, here we go. So we see right here, this is a list of VMs. And you can see here, a lot of my testing I did for this presentation was down here at this lower level with the standard D2 SV3 and the standard D4 SV3. Right here, you can see, if you can see my mouse, we're talking here the throughput, where we have the IOPS, the big number here, the 4,000. We have the megabytes per second. That's your throughput, 32 megabytes per second. And as you go up in the higher levels, which of course costs more, you can have up to 128,000 IOPS or a throughput of 1 gigabyte per second. Already started mentioning the idea of dependent and independent throttle points. Excuse me for a sec. All right, I had to cough. Anyway, so we talked about the dependent and independent throttle points. So if we go back here, you can see where you have your disk level throttling and then your VM level cache throttling. So the disk level throttling is usually an independent throttle point, while the VM level cache throttling is a dependent level throttle point, meaning that if the disks exceed their performance, it's not going to necessarily affect the performance of the VM. But if the VM exceeds its capacity, it will affect everything else. Something to be mindful of when you're doing your pricing and your sizing. But you also can never forget about the network. Your network is going to be your biggest bottleneck always, because every single connection is going out via a network connection, over the network, all of your disk requests are. So you need to make sure that there's a big enough pipe in place. So talking about capacity, I did mention it right here. So again, it's not a space thing. Each disk in Azure does have multiple maximum capacities, and they have nothing to do with space. And the main ones we're going to talk about today are going to be the IOPS and the throughput. So again, IOPS are your input output per second, and your throughput is the transfer of data, usually measured either in bytes or megabytes per second. As you can see here, looking at the premium SSD sizes, and so I believe it was Robert who was asking about the different levels of storage. The 4 levels of storage that are available in Azure is that you have your standard HHD, your classic rotational hard drives, you have your standard SSDs, then you have your premium SSDs, and then finally you have your ultra disks. This presentation is going to be talking about premium SSDs and ultra disks. But as you can see right here, this P30, which is going to be the example for use for parts of this presentation, we have a size of 1 terabyte. The maximum IOPS for this individual disk is 5,000, and the throughput for this disk is 200 megabytes per second. So going back here, looking at this VM list, you can see right here, it's important to keep track of the size of the VM, because you want to make sure that you have enough room for disks. Now, it shouldn't even be on the smallest VM right here. You still have room for 4 data disks, which should be more than adequate for laying out your SQL Server environment properly by having an individual disk for data, 1 for logs, and 1 for tempdb. But going back to this, so this again, these are the capacities, these are the caps that have been put in place by Microsoft on this disk. So assuming that this was your data disk, and this would be a good size to put in there, you're allowing for a maximum of 5,000 IOs per second, IOPS, input output per second, and a throughput of 200 megabytes per second. But it's not an and, it's an or. Talking about these basics again, IOPS, operations per second. So that's just the actual operations that are happening on your server, whether it be a request to disk, whether it be a transaction, anything right there. Throughput, the amount of data moved back and forth per second. IOPS are going to be much more, usually kind of a classic measurement would be your OLTP type of database, where like a point of sale system or something like that, where you have lots of random actions that are going on, changes being made to the database at all times. Throughput, you're going to see more classically in your data warehouse environment. You're going to be worried about how much data could we be moving if we're having to refresh the data warehouse. Latency, the amount of time it takes for an action to complete. As I said, that in a gaming environment, your latency would be where, again, if you click the mouse and you're waiting for the character to shoot their gun or something like that. That latency is also going to be experienced by your users. So when they click, let's say they're trying to generate a report in their system and they click on the mouse for that report to be generated, that latency is going to be how long is it going to take for that report to show up on their screen, or how long is it going to take for it to print out. Latency is the measure that is going to really bite you as you go through this working with storage and the throttle points in Azure. QDEPs, again, the measure used for the number of outstanding IOs assigned to an individual disk or disk array. That's how much work is stacked up waiting to go. Outstanding IOs, the actual workers ready to go on a disk. Why is this important? We've gone over this point again, and then we'll go over a few more times, because this is how your performance is doled out to you as a customer. It's important to understand so you can optimize your budget. These are old terms. They've been around as long as we've had disks, but they're still very relevant. And it's important to have at least the understanding of the basics to move forward and to make a educated decision as a consumer. So once again, we're looking at our P30 example. Again, you have these capacities that are allowed for you based on what you've paid for. And one of the things I wanted to point out here too is you can look at the smaller sizes of disks. And it's not an accident if you notice that we have roughly 50% plus about 10% in the sizing of the disks. So premium SSDs came out about 2 years ago. I think it was 2017, 3 years ago. And they were a great deal because it was all of a sudden they were finally going to be giving better performance. But one of the problems is for premium SSDs is that you have to increase the size. You have to double the size in order to get the performance level that you want. So for instance, you may look at this and say, well, I really only need a 128 gigabyte drive. But the problem is that you only have a capacity of 500 IOPS from the disk or a throughput of up to 100 megabytes per second. That could be a problem. And we're going to go through this very specific example in this webinar, looking at that, where you can see where it's so easy to hit this capacity point. So in order to increase it, you have to allocate a whole terabyte of drive in order to get this 500 IOPS per second and this throughput of 200 megabytes per second. Or I shouldn't say and, or. It's or. It's always or. It's a combination of these different characteristics, but ultimately you can't exceed either one of them. So it's just the way that it was designed. It's just not always optimal for your environment, and you're going to be paying for some more space. Now, I can say that I know that it's about 127, 133 a month for one of these P30 drives. So for a big business, it's probably not horribly expensive in order to do that, but it's still something to keep in mind. So we're going to talk about synchronous IOs. Synchronous IOs are a lot easier to figure out, but again, we're talking about your processes where you're writing to your logs or if you're writing to your backups. synchronous. Again, the concept is that each transaction has to be written to the disk before the next one can be processed. So going back to the P30 example with 5,000 IOPS, 200 megabytes throughput, average latency in the Azure storage environment is 2 milliseconds. That's a fact. You can look that up and find that. That's what they're guaranteeing. So let's think about if we had a single SQL Server instance, and we had, let's say we had one database on it, and that database is writing to the log disk. So that single threaded sync IO transaction is going to be, let's assume that's going to be 500 IOPS. So that database is going to be using up roughly 1/10 of the performance of that disk, because that's all it requires. Is that every second that is writing to the log disk, it's going to be doing 500 IOPS. Because you can see, and that's what's allocated. I mean, it can't do any more than that based on, well, 1 second is 1,000 milliseconds. So you divide that by 2 milliseconds, which is the latency, and you get the IO that's allowed for that one transaction, which is 500 IOPS. So let's assume that you had 10 SQL Server databases on that drive in that instance, and all of them are writing to the logs at the same time. So all of a sudden, each one of them is generating 500 IOPS. So 10 times 500 is 5,000. So all of a sudden, if you have 10 active SQL Server databases writing to log, you just maxed out that disk. So you can see how it's actually fairly easy to get to this point. Here's my fun little crude pictures right here showing you how outstanding IOs can work in a synchronous environment. Right here, the whole idea is that each one is that the IO has to wait outside the store to go in. They do their processing and then they go. So the store is representing the disk. Same sort of concept here is that this store, so this would be the smaller disk. Remember when we talked about right here, the P10 drive, that is up to 500 IOPS per disk. So in this top example right here, this is, even though I said P30, this would be your P10 because it can only handle one process at a time. If we go down here to the bigger store, it can process 10 workers at a time. And I'm sure there's some sort of connection to the lines that are outside the stores. Like I know that Costco had a lot of lines, but same sort of concept is that only so much work can get done at one time due to the limitation of the disk. This is what you've paid for as a customer. Now let's go to asynchronous IO. So it gets a little bit more complicated. We're doing the same P30 example with 5,000 IOPS and 200 megabyte throughput. Let's just assume, so SQL Server, most of your transactions are going to be, average block size request is going to be 256K. Now, even if the actual request is 257K, SQL Server is still going to pull 2 block sizes of 256K. It's just the way it works. And in asynchronous IO, which is your basic database, 95% of your transactions are going to be asynchronous. So they're going to be coming in from all over the place. It can be random requests. It can be all over. Once again, you look at your math. So let's assume that your database is doing, you're having 500 IOPS, because that's all you can do based on the latency. Again, 1 second equals 1,000 milliseconds with a latency of 2 milliseconds. That means that the max you can do on that drive that any one request you can do is 500 IOPS. So you multiply that times 256K, and all of a sudden you got 125 megabytes per second. So when we're looking back here at this drive, you can see here that it's pretty easy to get to this throughput level as well. Back on this little P10, you've just exceeded that throughput. And even on here, on this P30, up to 200 megabytes per second. So you're not going to have It's not quite like with my example here where you're going to necessarily have 10 outstanding IOs. Well, I mean, you could, but it's not going to be as simple as synchronous. You're going to have random requests, but they're all going to be pulling their own amount of data. And it would be pretty easy for it to exceed that maximum throughput. Here's another cat picture right here to explain how I think of asynchronous IO. What's more random than a bunch of cats in a room? And this is where I said that this is an OR equation. It's not an AND equation. So as you can see right here, depends on what sort of request that your database is doing. So if it's max IOPS, if you're doing a lot of little tiny transactions, that means that the maximum throughput you can have is 40 megabytes per second. But if, on the other hand, if you've managed to size your IO so that you're doing one megabyte transactions or IOs, that means that you can only do 200 of them, but you can reach that 200 megabytes per second throughput. Or you can do some sort of a blended sort of approach where you have 64K size IOs, and you can do up to 3,200 of them, and you can still meet that throughput. Or you can do smaller size IOs, so you can do a lot more of them. So you can see right here, it's pretty easy to reach that max. But it goes back to basics still on the layout for it. So because of this, because we have this blended environment, it's more important than ever to make sure that you've isolated the different types of transactions. So again, as we laid out, is that your backups and your logs are synchronous IOs, while your data transactions are going to be asynchronous IOs. Because of this, you still want to put your data on its own drive. You want to put your logs and probably your backups on the same drive. And then tempDB is going to be on its own drive as well. We talked quite a bit in this lift and shift webinar talking about the performance characteristics about the tempDB using the local SSD. As we go back up here to this right here, you can see that on the VMs that they each come with their own temp storage DB or temp storage drive. And this would be best practices, is that you want to go ahead and put tempDB from your SQL Server environment onto this drive. Usually shows up as D, but I think you can change that drive letter easily enough. But you're going to get the best performance, and we'll talk briefly about why that's a good idea. And the main reason is because it is a local SSD that's attached directly to the server rack that you are having your Azure service on, which is going to remove a lot of the extra layers that are keeping you from getting good performance. But now let's go ahead and take, let's go ahead and take this example of the throttling where you can see where it can start getting uglier. So remember, there's 1,000 milliseconds in a second. And we know that the average latency guaranteed to you by Microsoft is going to be 2 milliseconds. But what happens if you took that original disk where you had a limit of 5,000 IOPS and you had 10 database instances on there? Let's say that you wanted to add another 5. And let's say they're all just as active. So all of a sudden, you have 15 outstanding IOs. Each one is sucking up 500 IOPS. And guess what happens? You now have a demand of 7,500 IOPS. But Azure says, well, that's fine. If you want to do that, guess what happens? So it's going to take the number of IOPS that it can guarantee you per second, and it's going to give you this latency right here. That's what's going to happen, is that you still can't get any more than 1,000 milliseconds out of a second. So if you need to have extra IOPS, well, the latency is what pays the price. Let's say you added 20 databases to that single SQL Server instance, and they were all pointing to the same log disk. All of a sudden, you have an average latency of 4 milliseconds. And if for some crazy reason you want to have 50 databases on the same instance, you're going to have 10 millisecond average latency. It's painful. Just think about it. Another cat picture. This is what happens when you bang your head on the ceiling. So here's a little example right here in my demo environment where I was doing some writes here. Now this was using a P10, and I'm not going to scroll back, but again, the P10 is the one that has a max IOPS of 500 per second, or IOs per second, and a throughput of 100 megabytes per second. In this test, you can see right here, if you add 105 with 448, well, that means that we're going to have 553. That is greater than 500. So what I've done is I've exceeded the IOPS. And the best way that I have found in the Azure world to see if you have a problem, the canary in the coal mine, is to look at the queue depth. Because look what's going on right here. This is Azure's way of saying, hey, I'm in pain right here. You have a problem. So right here, again, we've got 500 IOP, we've got 553 IOPS that we're trying to drive through this disk at this one single point in time. And because of that, we have a corresponding queue depth that's out of this world. We have right here, it's about 87 right here according to the number. If you go up here, you get up to 120 almost. So that queue depth is because that latency is coming in place, and your requests are being put to the back of the bus, for a lack of a better term, because they have to wait. They have to wait in line. So recognizing that this was a problem, I looked at my drive, and here you go. Here's the P10 drive, which is 128 gig in size, and it has an IOPS limit of 500. And it has a throughput limit of 100 megabytes. One of the really neat things about Azure is it's super easy to allocate this stuff on the fly. You do have to shut down your VM, but you can just do it. And all of a sudden, look, boom. So I went from a P10 with a 500 IOPS cap to a P30 that has a 5,000 IOPS cap. All of a sudden, you can see that it was like night and day, going from this little cap of 500 IOPS per second all the way up to 3,000. So this is what my testing was wanting to do, but it was artificially limited because of the storage level that I had chosen for my environment. So again, going from 550 being capped out, causing a queue depth and causing pain for the rest of the environment. So, I mean, if you had this going on, your users would just be screaming because nothing would be working. Everything would be waiting until this finally got finished. All of a sudden, boom, you can do the work that it wants to do. And it gets worse. So even though the measurements that you're seeing, your IOPS and your throughput, are per the second, Azure is actually checking that limit every 50 milliseconds, not every second. This is where you have to go to the back of the line. You have to go to the back of the bus. You get to the bank and you're trying to, say you're trying to deposit a check and you forgot your ID. Well, guess what happens? If the teller's not nice, they're going to say, well, you need to go back to the back of the line and let these other people come through. That's what's happening here with Azure. If you have not paid for the level of capacity that you desire, that you need for your application, your SQL Server, whatever it might be, all of your outstanding workers have to go back to the back of the line and wait until their chance to go through comes up. And every time you do that, that latency gets higher and higher and higher, because once again, they're preserving integrity. Integrity is the most important thing. This is a good thing, but it does mean that your performance will be sacrificed. So we go back here, and now this picture may make a little bit more sense. So we were just talking about the storage level. Again, having disk level throttling because the disks were not sized properly. And sizing means it has different dimensions now. We're not just talking about the capacity of the disk, we're talking about the sizing as far as the performance sizing as well. But so then again, it's just not disks. So what's the other here? So we know that in this P30 example, that it has up to 200 megabytes per second and 500 IOPS. But here we're looking at my test server again. And what we have here, this is, I'm testing IOPS right here. Or no, I'm testing throughput. So in Azure Monitor, another, you're gonna get tired of hearing this. I have a lot of webinar ideas that I wanna do. And Azure Monitor is the awesome tool that comes with Azure. And I wanna teach you how to use it so you can figure these things out for yourself as well. But throughput is calculated by adding up the disk read bytes per second and then the write bytes per second. And as it shows you right here that we are capped at like right around 32, 33 megabytes per second. But how can that be? Because I paid for a P30 that has 200 megabytes per second. What's going on? I didn't put a header on here, but this one, if you do your math, you can see right, like I said, about 33 megabytes per second for the throughput. And then this is queue depth right here in this Excel diagram. And you can see that these are crazy numbers. We're going anywhere from the high 30s all the way up to the 250s. So looking at the drive, that's not the problem. It shouldn't be because we've paid for that level. I'm gonna mute it while I wait for this phone to finish. Okay, I'm back. That some wrong number that calls. Anyway, so as I was saying is that we know that we've paid for this sort of level of throughput on the storage level. So guess what's happening? You're hitting the VM level. This VM, this little, this small VM, the standard D2S V3, look at the throughput, max throughput, 4,000 IOPS and 32 megabytes per second. And what was this number right here? 33 megabytes per second. So this server now is that this is where you have dependent level throttling. Disks are independent, server is dependent, which means that if the server ain't happy, no one's going to be happy here. So it is not going to let you move forward until you fix this problem. Again, we have our disk level throttling, our independent throttling, and then we have our dependent level throttling at the VM level. And on a little side note, remember when we were talking about the why I recommend that we put temp DB on this drive right here. See right here, it doesn't have to go through all the different levels. Because here's your virtual level right here, your virtual machine, and this has a straight pipe right here to the server SSD. Now they're still throttling, but the point is it doesn't have to go through quite as much as right here in order to get to where your storage is. So again, we just went over this whole concept, but second pass, because this is complicated. So you have your dependent and you have your independent throttle points. So the disks are independent, but when the VM reaches a capacity, then it will delay all other transactions. Guaranteed. And right here, like I said, queue depth, you can see here where you have the canary in the coal mine, and you can see that this is a problem. And this is a period of about an hour and a half, because I was really hammering this test server. But that was a solid transaction of 250 outstanding IOs were queued up waiting to get on board that drive to go into the post office and send their mail. I mean, however you want to look at whatever analogy you want to pick. The point is that this server was crying out in pain because it couldn't go any faster. It was stopped. And right here, so what I did though, is I went ahead and clocked up to another level. Let's see, did I put this right here? So I went up and I went ahead and I upgraded the server and I went up to this next level, this D4S. And all of a sudden, look at the throughput. It has a 64 megabyte per second as compared to the 32 megabyte per second. So now all of a sudden, if you look at this number over here, you can see right here about 62, 63 megabytes per second. It's still capped out because of the type of testing that I was doing on the server. But the point is that it allowed it to go a lot faster. So again, the point here is that it is artificially being restrained because of what level I paid for on the server. So it's not just disk, it's also the server as well. And then here from Excel is where I took all the data that I was reading. And you can see right here where you have here's the IOPS right here, or no, this is throughput. So I took the math over here to show you what the megabytes per second is. QDEP, as I said, that even though I increase the level, obviously I need to increase the level of the server a few more notches. But the point is that this was in test, and this is something that you can take back to your enterprise and you can go through and figure this out yourself. Or you can ask Pragmatic Works for help. Shameless plug. And then also you have your read IOPS. So you can see here that there wasn't a whole lot of writing going on, but it was sure reading a heck of a lot. And it allowed it to get through this point. So until your Q depth gets down to a normal level, which is like this 3.26, I mean, you want to make sure that the drives are being used, but I wouldn't recommend a Q depth of any higher than like maybe 10 to 30 on any single drive, because anything more than that means that you've just overburdened the drive. It's a lot of stuff. Another cat picture. So the throttles, I think this picture right here is a little bit better explanation of why we have some latency built into the storage level. Now over here on the right, you can see right here, you can see the Azure Blob Cache driver. So up until UltraDisk came around, all of the storage was in the Blob Cache. And if you look at these different pieces right here, and look at all the different steps that go through. It goes through this front end, the partition servers, the stream servers, and finally getting to the storage devices. So that's a lot of steps. This is why Microsoft guarantees you that you'll have a latency of 2 milliseconds. That's because there's a lot of points that have to go through in order to go ahead and deliver your request to storage, retrieve the data, and bring it back to you. Why, on the other hand, UltraDisk, the brand new, the virtual disk client, it goes right to the storage servers. Guess what? You don't have all these layers of obfuscation going on. You get right to the storage servers and get your request taken care of. That's pretty cool. Comes at a price. So here's your P30, and then it also fixes the other problem, which is that you have to buy a really big drive in order to get the level of performance that you want. So instead, UltraDisk allow you to scale that out appropriately. Unfortunately, the disk sizing is the cheapest part of the whole equation. But as you can see here, you can go all the way up to 160,000 IOPS on a single disk. I believe that I didn't put the right chart on here, but I think that even going up to a P80, I don't think you can get above something like 60,000 IOPS. So you're still pretty darn limited here. UltraDisk, you can size it out, and you can also increase your throughput. And you don't have all of this extra stuff right here going through the Azure Blob Cache driver. It comes at a price. It comes at a huge price. But if your enterprise needs to have that level of performance, then you need to look at UltraDisks. As you can see here, this is from the Azure Marketplace when I was building a VM. It's pretty simple. You get to just choose. You look at this chart right here, and you can see what the capabilities are and capacity is, and then you just size the disk. So this is when I was making just a little tiny disk hard drive for doing TempDB. I wanted to have lots of good IOPS because I knew it needed for TempDB type activity, but didn't really need throughput. And that's it. So what didn't we cover? We didn't really get into caching. We did cover it somewhat. So the main thing to remember is that caching recommended best practices by Microsoft is that you need to recommended that you do read caching on the data drives, and you do no caching on the log drives. We'll go into more detail in another webinar. We did not cover how to use Azure Monitor, but as you can see, I depend heavily upon Azure Monitor in order to analyze what's going on to the Azure environment. You can still use Perfmon, but Azure Monitor is so much easier. It just does it all for you. And plus it dumps everything to Excel spreadsheets for you. I have already got plans I'm going to be doing. I want to do a step-by-step guide on how to set up Azure and monitor in your environment and how to read it. We also didn't talk anything about Azure SQL. I know that I put that in the description. We're going to talk about that. I will be talking about that in yet another webinar. There's only so much time here. Azure SQL is a lot simpler, but I think there's some important things to keep track of. And I want to show you a fun example that I ran into in a previous environment. What do we cover though? We went over some basic performance tuning concepts. Pull out your old book from 10, 20, 30 years ago. All that stuff still applies. It's good to refresh your memory. We talked a lot about throttling in the Azure world. That is the main thing to keep track of. It's going to happen. I know that in my previous webinars, I'm always stressing working with the business and working with the infrastructure team that it hasn't gone away here. Trying to give you some tools that you can use so you can go have a reasonable conversation with the infrastructure team, whoever is responsible for administering your Azure environment. And you can take the output from Azure Monitor, and then you can see what's going on in your environment, and then you can look and make an educated business decision. Premium and Ultra Disks. It's hard to recommend anything other than these two options. I understand that your mileage may vary and your cost may vary, but if you're dealing with a database, you need to have high quality disks that are going to be able to handle throughput. If not, the lower levels are good for backups, archives, but if you're doing active applications, you need to have these high quality disks. Now, Azure Monitor talked about it again and again. We are going to be doing a webinar on Azure Monitor. Finally, it's complicated, but I know that Pragmatic Works will be able to help. So I know that the generic email is hello@pragmaticworks.com. So email that and someone will be happy to talk to you, or email me and we'll get you the right people. The main thing is that I want you to be empowered here. The documentation is complicated. You can also go through and read the documentation. There's a lot out there. Some of it's up to date, some of it's not. It's all the information is out there, but maybe Pragmatic Works, we can help you come up with a plan. So anyway, let's take a look at the questions and see if there's anything out there. And if I can just do this right. Okay, let's see. Thank you again, Don, for your comment. Robert, thank you. OpenVMS. Well, I didn't even get to work on OpenVMS. I had to work on, I worked on old VMS. I worked on VMS 5.5, but it still has most of the same commands. As Crystal answered, is that all these webinars are going to be posted. They're going to all be posted on, if you go to the blog site, you will get an email. I know you will get an email showing you where the link is. I think you do. Crystal, did they get an email or not?
Yeah, they get an email, and all of our webinars are on our YouTube channel under our free training playlist as well. Okay,
fantastic. Yeah, so please, and you know, I can only improve. So you know, please ask questions, please offer comments. That's fantastic. Let's see. So a fellow person named TwoCert, the traditional usage of gigabytes and megabytes, how does it translate to Azure gigabytes per second, megabyte? I guess if you want to send me an email, we can talk about that. I'm not quite sure. It's still the same concept. It just that Azure is measuring it the same way. It's still megabytes per second, gigabytes per second. Which situation warrants asynchronous IO? So again, that's 95% of your database requests are going to be asynchronous IO. It's not so much a situation. I mean, or are you? Let me take a guess what you're asking here. Your 95% of your requests in any database environment are going to most likely be asynchronous IO, but that's more of your classic OLTP sort of environment. Your database, your data warehouse is going to be more synchronous IOs because it's going to be all about throughput. It's going to be shoving data from one or more environments into a single repository that then your users can do reporting off of however they want to use that data warehouse. So it's not so much a I mean, I guess that hopefully that answers your question about situation. If not, feel free to email. We can talk about more. What is a block size request? So that's just a request for data. If you send a request to the database and you say that I want to pull up a record of all the vendors, it's going to do enough block size requests in order to pull the requests that you have. Paul, so are you saying Azure stinks if you don't pay for the highest premium SSD? Unfortunately, yeah, it really can. It really can. I mean, you're paying for that performance. So that's where you need to sit down and use your Azure Monitor tool, look at what's going on, and see I mean, that's all there is to it. It takes time. It's not the simplest process, but it's not that difficult. It's just you just have to go through an iterative process. Ideally, you can do some testing. If you're lucky enough to have some sort of a test environment, you can go forward that way and make changes. Otherwise, you have to kind of guess. And you have to say, back to the business and say, well, I think based on the fact that I've been seeing that this log drive has been pegged at 500 IOPS for the last 2 months, that we might want to investigate putting a bigger drive in there. And then you have to go back and look at that performance. Luckily, the cost is not huge for changing out the storage level, and it's easy enough to change it back and forth. Another question, do you recommend any other book sources other than Azure Documentation Learning Path? So Microsoft Learn is awesome. Microsoft, it's such an improvement from the virtual Microsoft Academy or Microsoft Virtual Academy that was out about 4 or 5 years ago. I had a lot of fun going through when I passed my AZ 900 test, going through the learning path. It's fun to earn the badges. But the Microsoft documents, Microsoft has they've committed to making sure that their documentation is up to date. And I've had the pleasure of talking to a couple PFEs, premium field engineers, about the process. And they were just told, you have to make sure this is up to date because this is the type of company that we are. And it's extremely useful to know that you can go out there and you can trust all this documentation. The problem with is that Azure is changing so quickly that sometimes they may be a little bit behind. But the point is that 99% of the information is going to be relevant. And one of the things we didn't talk about here in this webinar about the bursting. So even though we talked at length about the capacity as far as like the IOPS and the throughput, so one of the new things that was added was the whole bursting. And so that for every hour that you're not using bursting, you get a certain few minutes of bursting time, which means that you can temporarily exceed the capacity without having that latency penalty. If you go to the storage sites, just do a search for Azure storage. I mean, here we can, let's hit this, kill this. We go right here. I got all my crazy websites. Right here, the point is that you can go, here we go, manage disk. If someone asked about pricing, here you go right here. If you go right here, if you do a search for Azure pricing details, managed disks, you're going to be able to see that, find out the information. I guess the point is that it's not too hard to find this information. And yes, I'm thinking out loud. Anyway, just start doing searching. You're gonna be able to easily find a lot of information out there, but stick with the Microsoft documentation. It's gonna help you out quite a bit. Anyway, any other questions? But I want to thank everyone for showing up, and for all of you that showed up for all 5. I can't offer you a t-shirt or anything, but I do appreciate you showing up to all of my webinars, and I hope that you enjoyed them. And please don't hesitate to offer comments about them as well. So thank you very much. Thank you, Crystal, for managing all of this. This has been a little bit of an adventure.
No problem, Michael. Thank you so much for hosting 5 webinars back to back. We greatly appreciate that. And for anybody else, like Michael was stating before, you guys will receive an email of the recording of this tomorrow around noonish Eastern Standard Time, so please look out for that. Also, all of our webinars, past, current, they're all on YouTube under our free training playlist. Just go under Pragmatic Works and then click the free training playlist. But if you guys have any questions or can think of anything in between the meantime or after, please feel free to reach out to Michael or myself. If you guys are interested in any of our DBA managed services offerings, please click the link that I have put into the chat for everybody. And thank you guys so much. We hope to see you guys in the next webinar. Enjoy the rest of your evening or day or afternoon and stay safe. Thanks again, Michael. We appreciate it.
Thank you. Pragmatic website here. You can see where all the webinars are, and the archive ones are right here too. So easy to find this information.
Yep. Really, really easy. And like I said, they're also all on YouTube as well. So you can catch any from current years to the past 2 or 3 years. So if you guys, like I said, have any questions, please feel free to reach out to Michael and myself. I hope you guys enjoy the rest of your Tuesday and have a wonderful day.
Yeah, one of the things that here you can see on the blog, so if you go to blog.pragmatic, you can see the older webinars as well as all the other videos that we have out there too.
Yep, so also visit and that's also going to be in you guys' email as well, the blog.pragmaticworks.com for our blog as well. So that'll be in the email as well as our DBA managed services offerings and as well as the video link. So if you guys have any questions, just stay tuned for that.
Yep. Thanks again, everyone.
Thanks, bye.
Bye.